Okay, so let's move on to the second part of the challenge of the selected problem to chapter 20 from the AoPS Volume 1. So the triangle ABC is inscribed in circle O. So let's draw a circle of the O. And we have a triangle inscribed here. It's the ABC. A circle with the center I is inscribed in the ABC, and AI is drawn. Okay, so the in center is the intersection of the angle bisector, right? So this is I. So if we draw the AI, right, and extend it to intersect the large circle at the D. Okay, because this angle is A over 2, right? So this arc is A, and this arc is A. The measure is the angle A, right? The D, so D is the BD arc is equal to the CD arc. Prove that D is the circumcenter of CIB, right? So we want to prove D is circumcenter of CIB means if D is center means we want to prove the DB equals DI equals DC, right? This is a very important result, okay? This is called the in-center, X-center lemma. If I remember correctly, it is the event by the event chain. Here's the IMO gold medalist, okay? So let's prove it, okay? So here is the B over 2, here is the B over 2, right? This is the A over 2. So you can see this angle is the external angle of the triangle AIB. So this one equals A over 2 plus the B over 2, right? And this one is because this arc is DG is A, so this is A over 2. So this angle is also A over 2 and B over 2, right? So now you can see the triangle of the BDI is the isosceles triangle. So you can see it's BD equals DI. This is the first part, right? And the second part you can see is the BDC, okay? The BDC, right? So this angle equals to this angle, right? So it's A over 2. This is A over 2, right? Because this A, so we have the BD equals CD. So BD equals CD, BD equals DI. So now you have the DB equals DC equals DI. Now you prove D is the center, okay, of circle of BIC. Okay, this is very important result, okay? Yeah. So next, so if we have a square, okay? We have a square of 12-inch side. Now we have the A, B, C, D. We have 12-inch side. The segment AE is drawn where E is point on 5 inches away from the D. So E is 5 inches away from D, so this is 7 inches. Then the perpendicular bisector of AE. Okay, so here we have the perpendicular bisector of AE is intersect on the PQ. Okay, so since this is the perpendicular bisector, it's 5, 12, right? Though we know it's 13, so it's 13 over 2, and this one is 13 over 2. Okay, so 5, 12. This is the right triangle, right? ADE, so you know it's 13. And what we are going to solve is the PM over MQ. So PM over MQ is the hypotenuse, right? So it's better we can convert and use the similar triangle. Okay, so let's do it. So passing M, let's do a CD. We do a GH. Okay, parallel to the AB, so we know it's 12, right? So because M is the midpoint, so G is the midpoint, right? If G is the midpoint, so it's 5 over 2. So now we know the triangle PMG is similar to triangle QMH. Then we know the PM over the QM equal to the GM over MH. Okay, so the GM is 5 over 2, right? So the MH is 12 minus 5 over 2. So this one equal the 5 over 2. Then this is the 19 over 2. Equal 5 over 19, right? So 392. This is an important result. Okay, so we have a triangle ABC. Okay, so now connecting all the points of the contact of the sides of a triangle, and it's in circle. Okay. So let's find the in center first. So this is the in center, right? And now we can know there is a so this is the R, this is the R, this is the R, right? So D, E, and the F. Now we can connect the DEF. Okay, so this is the A over 2, A over 2, then B over 2, B over 2, then C over 2, and C over 2, right? So since we can have multiple cyclic quadrilaterals, the first is AFIE. Okay, second one is the BFID. And the third one is the CEID. Okay. The reason is I give you one of them. Okay. So let's see the AFIE. Okay. The AFIE you can see because I mean here is the 90 degree and 90 degrees, so this is 180. That's why they are equal. So now we have this one is A over 2 and A over 2, right? And now let's change another color. So in the BFID, right? So here is the B over 2. here is the b over 2, right? And the last one is the c, right? So c over 2 and the c over 2, right? So we want to prove that DEF is a acute triangle, right? Means let's assume without loss of generality, we see A less than equal than B less than equal than C, right? So now in the DEF, right? So the angle of the AB, I mean the angle F, right, is A over 2 plus B over 2 will be less than the A over 2 plus the C over 2 less than B over 2 plus C over 2, right? So we want to prove this two angles at is greater than the 90 degrees, right? So we have the A over 2 plus B over 2 plus the A over 2 plus C over 2, right? So this part is 90 degree, 180, right? So 90 plus A over 2, so it's greater than the 90 degrees. That's why, I mean, this triangle must be a acute triangle. Okay, this next question. So we have the two circles in the diagram in circles A, B, D, okay. So we have the A, B, C, and we have a D. Now we have because it's we have the tangent, I mean we have the incenter, right? We have the incenter. Okay, so we have this one called P, this incenter called Q, right? Then we connect them together, okay? So because, I mean, they all touching at one point, right? So if we do the 90 degree here, this is the G, and we can, this is also this same touching point, so we know the PGQ is collinear, right? PGQ is a line. Okay, then we know this is 290 degrees. And the other thing is if we parameterize this one as alpha and alpha, right? So this one is equal to the angle A minus alpha over 2, right? It's the same thing. Okay, these two are the same. Also, if we know this angle is beta and beta, right? So this angle is the 90 minus beta and 90 minus beta. Okay, so that's why we can see this angle is 90 degrees. All right? Okay, now we want to see if AB equals C, then AC equals B, then BC equals A, right? We want to find the BD. We want to find the BD, okay? So now let's see, let's land a height here, right? So we know the triangle, let me give you the color, okay? We know that the triangle PEF, okay, PED is congruent to PGD, okay, common side, right? And also this is the radius of the incircle. This is radius of incircle, so that's why they congruent. Once they are congruent, then we have the ED equals M equals DG equals M. Then the similarly we can see the GQ D is congruent to FQD, right? So here is also the M. So now we can see, in order to solve the M, right? It's the M is equal to the, in the triangle ABD, right? So M is equal to the AD plus the BD minus the C, right, over 2. Triangle ABD. And the triangle of the ACD, you can see the M is equal to the AD plus the CD is A minus BD, right, minus B over 2. Then the M equals M, right? So you can see AD can be cancelled. So BD minus C over 2 is equal to the A minus B over 2 minus BD over 2, right? So by solving this, you can see BD equals the 2A plus C minus B. This is the first part. Okay, so the second part, if the two radius are R and S, right? Because P is the incenter, so PG is R, QG is S, right? So you can see the PDQ we talk about, right? This is the PQ and D is a right triangle. So here is the height, right? So you know this is R and S, right? So that's why the DG square is equal to the R times S, right? So this one is equal to root R times S. Okay, then next is in triangle ABC. C, A, B. With the median of AE, so E is the midpoint. BF, F is the midpoint. Okay. AE, BF, CD. So this is the centroid G. And the EF FH is parallel and equal AE. This is the H. Okay, so if FH parallel or equal to AE, this means the AF HE is parallelogram. Okay, this means the AF also parallel or equal to the HE. Okay, this also means the CF parallel also equal to HE. Okay, then we can connect the CH. So this means the CFEH is also a parallelogram. Okay, so now we prove the AEFH. This one is done, right? First, BH equals DC. Okay, now let's prove the second one. So we already proved the CFEH. Okay, CFEH is a parallel. Is also a parallelogram, right? Now we have the CH parallel or equal to the EF, right? And and also because this is the half, right? And this is the midpoint, we know the EF also parallel or equals to BD. Then we know the CH equal or parallel to BD. Then we can know that the CHBD is also a parallelogram. Okay, so that's why you can also see the BD equals CH and also BH equals CD. Okay. 3 is simple, right? Because the FE is the midpoint, right? You extend this, and this one is parallel here, right? So that's why FG is the median of the FG. E. Okay, I'm sorry. This we cannot do the G. Okay, call the P. This is the G. Okay, so FG is the median of triangle BFH. BFH. Okay, yeah. So you can see the ACHB is a trapezoid, right? So the F is the midpoint. So the F is the midpoint, right? And the FEG parallel to AB. So that's why you know G is also midpoint. If G is the midpoint, then you can see the FG is the median of triangle BFH. So the last one is FG is okay. So if we parameterize A, right? So now the AB equals 2A, right? So the FG equals half of the 2A plus half of the A is equal to the A is equal to 2A, right? Half plus 1/4 is equal to 2A times 3/4. That's it. Okay, the next one. So if we have a square with the side length is rotated, okay, so we have a square, then we're rotating this square, right? Yeah, so by rotating, there is a lot of symmetry, so that's why I talk about this problem, okay. Okay, so if you see here is the alpha, right? And that's without loss of the find the common area to both original square and is rotated by the angle alpha. Side length of 1. Okay, so we have the side length of 1, right? So this is all ones. Okay, then you can see because this square is rotated to here, right? So this point is to here, right? And this point to this point, right? And this point to this point, right? And this one doesn't change. So we know this angle is alpha, right? And then you can see the by the symmetry, right? You can see this triangle, right? Because we move this triangle here and my drawing. Okay, so we move this triangle here, right? And this one moves to here. This one here. This one here. This one to here. Okay, so by symmetry, we know this angle equals this angle, right? So this is 90 degree, this is 90 degree. So this triangle is congruent to this triangle, right? So if this is the 90 degrees, so this is the 45 minus the alpha over 2, right? This is the 45 minus the alpha over 2, okay? So we want to calculate the area of the of a PQR, right? So the area of the APQR is 2 of the area of the APQ. So the area of the APQ is tangent the PQ is tangent of the 45 minus alpha over 2, right? Okay, so it's half of the 1 times the tangent of the 45 minus alpha over 2, right? So it is the 2 times this, right? So that is equal to the tangent 45 minus alpha over 2. Okay, then we know the cosine alpha is 4 over 5, right? So 4, 5 is alpha, right? So the cosine alpha equals to the 4 over 5, then we know that this is 3, so the tangent alpha is equal to the 3 over 4 is equal to the 2 of tangent alpha over 2, 1 minus tangent square alpha over 2. So let tangent alpha over 2 is equal to x. Then we can try to set up the equation, right? So this one tells 3 over 4 is equal to the 2x and 1 minus x squared. So we have the 3x squared plus 8x minus 3 equals 0. So 3, 1, and 3, negative 1. So we can solve the x equal to 1/3. So tangent alpha over 2 is 1/3. Then this one becomes the 1 minus the 1/3, and the 1 plus 1 times the 1/3 is equal to 1/2. Okay, so for this problem is ABCD is an isosceles trapezoid. Okay, so we have a trapezoid of the ABCD. And the AD equals BC, let O be the intersection. Okay, so let O be the intersection, then we have the AOB is 60 degrees. Okay, in this case, let's parameterize AAA, right? Because we know this side equal this side by symmetry of the isosceles. We know this side equal this side, right? So this is the B and the B and the B. Okay, so the diagonal is the A plus B, and the MNP be the midpoint of so M N P. Okay, so the MNP be the midpoint of the DO or AO and that, okay? So prove the triangle MNP is a equilateral triangle. Okay. So to prove the triangle is an equilateral triangle, we'd better prove the three sides are equal, or we can prove it's a isosceles triangle, but with 60 degrees. Okay. So for this one, because this is 120, this one is 120, so I think it's easy for us to calculate the side. Okay, so let's put a line here, so we know this is 60 degrees, right? We know this is the 60 degrees, so this is 120 degrees, this is the 60 degrees, right? And the length of this is b over 2, right? And also we can solve this, right? So because p is the midpoint, so the t must be the midpoint, right? So the dt is equal to half of a plus b, right? And the dn, this is the n, okay? The dn is half of the b, right? So you know the tn is dt minus dn is a over 2, right? So now we have the a over 2, right? So you can see the NTP construct a triangle of the 120. So we have the b over 2 and the a over 2 and the 120 degrees, right? And also take a look at the NMO, okay? So we also have the b over 2 and the a over 2 and the 120 degrees, right? So if you see the extracted pattern here, so you know the mn equals pn, right? Okay, so similarly, we can also prove, okay? We can also extending this one to here, right? PTR, right? We can also see we have the PR and the M, right? So we have the A over 2 and the B over 2, then 120. Okay, so now you can prove the equals the PM as well. So by doing this, we can prove that this triangle is a equilateral triangle. Next one is similar triangle. Okay, I picked this one because I mean normally if it give you three sides, it's easy to determine. It's very normal way you can see how to define a triangle, right? But sometimes we have the different way to define a triangles. So let's see this, we have a right triangle ABC. It doesn't give you the length of the side. We have draw a height of the D, right? So we have multiple similarities here, and then we draw the angle bisector, right? So this one is a over 2 and a over 2. So we have, maybe we can apply the angle bisector theorem. Here is the P, here is the F. See, this one, it tells you AP is 12 and the PF is 8. It lets you to calculating the tangent BAF. Okay, so we want to calculate the tangent this, and also we want to get the PD. Okay, so so you see you didn't have any side, and the only thing you have is this all these similarities, right? So per the similarity, you know this is the angle C, this is the angle C, right? And this will be the angle A, right? So we can see, okay, so we can see the in order to try to fully use the 12, right, and the 8, we try to use the some similar triangle with the 12 and 8, okay. So now let's see if this side is C, so we can see the triangle of the ABF is similar to triangle of the ADP. ADP, right? So then we can see the C over the hypotenuse 20 is AD over the hypotenuse 12. So now we can parameterize it. So AD is equal to the 4, 5C, right? So this is a 4 over 5 times C. And also, also we can have the PD, right? So you can see the PD and let me see the similarities. Okay, so now we can see the cosine of the A, cosine of the A, right, in the triangle ABD, right? You can see the cosine of the A is 4 over 5 times C over C, right, is 4 over 5. Now we want to solve the tangent half A, right? So now we can see the cosine of the A is 4 and 5, so this is the 3. So the tangent of the A is equal to 3 over 4 is equal to the 2 times x equals tangent A over 2, 2x, 1 minus x squared. So now we can do that is the 3x squared plus the 8x minus 3 equals 0. So 1, 3 and 3 negative 1, right? So now you can see the x equal to 1/3. Okay, so that's why we solve the half of the tangent, right? So if we solve half of the tangent is 1/3, right? This one is 1/3. Half of the tangent, we know the tangent is 1/3. So this one is 4 over. So half of the A is 1/3. So this one is 10, right? So now you can see the 12 times cosine is 12 times sine half A is BPD, right? So PD is 12 times the sine A over 2 is 12 times the sine of the 1 over root 10. So it's 12 over root 10. So next is 399. Okay. So we want to find the length of the median of a trapezoid whose diagonals are perpendicular segment. Okay, so we have a trapezoid, right? We want to find the median of this trapezoid. That's the median here, whose diagonal are perpendicular. So whose diagonals are perpendicular, and 7 and 9, right? So see, we know it's 9 and 7. Then how to use it, right? In order to use the diagonal, instead of crossing in the middle, right? We want to do do a parallel line. So and we do this one parallel, so we can convert it into right triangles. Okay. So now we have this side is, for example, 9, and this side is 7, right? So now you can see you have A and B, right? We want to solve the what is A plus B over 2. Then this is the A. Now you can see the A plus B is equal to the 9 square plus the 7 square is equal to 81 plus 49 is 130. So this one is root 130 over 2. So question number 400. We have a triangle ABC. Okay, then this triangle has the area of the 10. Point D, E, F are all distinct to that. So AD equals to 2 and BD equals to 3. Then this is the E. Okay, so we know the D, B, E, F equal to the area of the ABE. Okay, so we can see we have a common area here, right? Let's see, this area is we have a common area of this one, right? So that means this common area plus the, let's see, this P. So the common area plus the FPE is the common area plus the APD. So triangle APD is equal to triangle FPE. So now let's see let's parameterize it. So this is the 3M, right? And this is the 2M, and let's see, this is the area is X, this area X. So this is the 2M minus the X. Okay, so we have the two common area. So the total area is the 5M plus X and 5M plus X. Okay, so if you see the triangle ADE equals to S of the triangle FDE, okay, equals the 2M. This means it has a common base, right? And that means they have the same height. If they have the same height, this is very important, okay? That means AF should parallel to DE. If AF parallel to DE, now you can see it. So this is the 3N, this is the 2N. You can also have the ratio, right? And if this is the 3N, this is the 2N, so you can see the triangle ABE is 3/5 of the triangle ABC. So it's 3/5 times 10 is equals 6. The last question is we have a triangle ABC. So M is the midpoint, and AN is the angle bisector. So A over 2 and A over 2. And BN parallel to AN, right? So you can see it's BN is perpendicular to AN. So you can see this the angle bisector and the perpendicular. The first thing we can thinking is to extend this line, right, to the Q. So you can see this is the perpendicular bisector, also angle bisector. You know the triangle BAQ is isosceles triangle. So once it's isosceles triangle, AB equals 14, so AQ equals 14, then this equals 5, right? And N is the midpoint, and M is the midpoint, so NM is half of the CQ is 5 over 2. Okay, so that's it for the selected problems for this chapter, and thanks for watching. And if you like this channel, just feel free to subscribe it. Okay, thank you, bye bye.